8.1, solving quadratic equations. We're going to use three different methods. We're going to solve them by factoring, by the square root property, and then by substitution. So solve by factoring is the first one that we're going to look at. And we have the equation x squared plus 5x equals 24. Well, what makes this a quadratic equation is this x squared piece. Okay, so all of these equations are going to be squared on the x. Remember, general form is to get everything on one side and set it equal to 0. So if I'm going to set this equal to 0, I need to move the 24 over, and it's positive, so I want to subtract it on both sides. So these would cancel, so that I have 0 over here, because 24 minus 24 is 0. I cannot subtract this 24 with the x squared or with the 5x. They're not like terms. So the best I can do is just write it horizontally. X squared plus 5x minus 24 equals to 0. So now that it's in general form, I want to factor this. Well, I'm looking for two numbers that when multiplied together give me negative 24 and added give me positive 5. So if I think about it, that would be a negative 3 and a positive 8. So I factor this side, it's still equal to 0. Remember our 0 product property, which is saying if two items are being multiplied together and it equals 0, one of them has to be 0. So either x minus 3 equals 0 or x plus 8 equals 0. So I'm going to solve each of these equations. I'm going to add 3 to both sides. Those cancel and I get x equals 3. Over here I need to subtract 8 on both sides, and I get x equals negative 8. So quadratic equations are typically going to have two solutions. So one of these solutions is 3, and the other is negative 8. Let's hop down here. I'm going to follow these same steps. I'm going to write in general form, step 1. Step 2, I'm going to factor. And step 3, I'm going to set each of them equal to 0. So if I'm going to get this in general form, I want to move everything to the left side. So that means I need to subtract 4. That way these cancel. I have negative 11x equals 3x squared minus 4. There's one more thing I need to move. It's negative, so I want to add 11x. These cancel. They zero out. I'm left with 0 equals. I'm going to write this highest exponent first, so 3x squared, then the 11x, and then the minus 4. Now that it's in general form, I need a factor. So I'm looking for like a reverse FOIL here. So I know that my first two numbers, when I multiply them, if I FOIL them back out, they need to equal 3x squared. So one's got to be 3x and the other's got to be x, because 3x times x is 3x squared. And I know that my last two numbers need to multiply to be negative 4. So if I kind of guess and check, numbers that multiply to negative 4 would be a negative 2 and a positive 2. But if you kind of think about it and FOIL it out, you'd get 3x squared plus 6x minus 2x. 6x minus 2x wouldn't give me an 11x. So it can't be a minus 2 and a plus 2. The other numbers that multiply to negative 4 are negative 1 and 4. And when I think about this, I'd get the 3x squared. I'd get 12x minus 1x. Oh, 12 minus 1 would be 11. So we're good. This is the factors that I want. The next step is to set each equal to 0. So my first set of parentheses was 3x minus 1. The second set is x plus 4. So now I'm going to solve these equations, figure out what x is. I'm going to have two x's. So I need to add 1 and then divide by 3. And x equals 1/3. Oops. Over here, I'm going to subtract 4. 0 minus 4 is negative 4. These cancel, and you get x equals negative 4. So I have two solutions here. The first one is 1/3. The second one is negative 4. Okay, the square root property comes next. Basically what it's saying is if you take the square root, like for instance, let's say we had x squared equals 3, and you're solving for x, and you take the square root of both sides, x is going to have two solutions. It's either going to have the positive version of the square root of 3, or it's going to have the negative version of the square root of 3. That's the square root property. So typically we just write it one way. We say x equals plus or minus, right? The positive or the minus version of the square root of 3. Why is that so? Well, you may be thinking, let me pick a different example. X squared equals 36. Okay. Well, what values could we put in for x? Isn't it true that negative 6 squared equals 36? And isn't it also true that 6 squared equals 36? So we have two different numbers, a positive and a negative, right? If I were to square root this, I get x equals positive and negative square roots of 36. Well, the square root of 36 is 6, so I get x equals negative 6 and x equals positive 6. Okay, so the square root property is just saying if you square root both sides, you're going to get a positive and a negative version of that square root. All right, let me give myself more room here. So let's try to use this square root property to help us solve this equation here. There's nothing really to factor, but I can get a little bit simplified. If I divide by 3 on both sides, that's going to leave me with x squared equals 5. Okay, remember our goal here is to solve for x. So what I want to do to get x by itself is square root both sides. Well, the square and the square root I know cancel, so I'm left with x. And because of the square root property, I'm going to have two answers. I'm going to have plus or minus the square root of 5. Okay, so anytime you square root both sides, you're going to have plus or minus. So that's my answer. So like if you were asked to put it in a decimal form, you would type in your calculator the square root of 5 and you'd get some number. And then in your calculator you type negative square root of 5, you're going to get some other number. But it wants it in simplest radical form, so this is as simplified as we can get. Putting it in WebAssign, it might let you do x equals negative square roots of 5, comma, positive square roots of 5. I'm not really sure how WebAssign wants it, but just be aware of that. Okay, drop down here. There's nothing that I can divide or subtract by on both sides. So I'm ready to get rid of the square root. So I want to square root both sides to get rid of the square. Square and the square root cancel. So I'm left with x minus 2 equals, well, if I square root this, I need the positive and negative version of it. So plus or minus the square root of 10. Now x isn't quite by itself. I'm going to need to add 2 to both sides to get x by itself. Okay, so my negative 2 and positive 2 cancel. I'm left with x. Now, over here, I have a positive 2, and it's either being added or subtracted to the square root of 10. Okay, so you can write it two different ways. You can write it 2 plus the square root of 10, and then you can also do the other version, or the other solution, x equals 2 minus the square root of 10. Okay, both are true. I like just doing one and saying plus or minus. So I do 2 plus or minus the square root of 10. Now, like I was saying earlier, if you type these into your calculator, you're going to type in 2 plus the square root of 10, and it's going to be about 5.16. If you type in 2 minus the square root of 10, it's going to be about negative 1.16. So these are two different answers. This represents two solutions for x. All right, the third one in C. Before I can square root both sides, I want to isolate the square. So I need to add 8. And then I get 8 equals 3x minus 6 squared. So now that the square is by itself, I'm ready to square root to get rid of it. Square and the square root cancel. So I have 3x minus 6 equals the positive and negative versions of the square root of 8. I want to make sure 8 is in simplest radical form. So off to the side here, I'm going to do the square root of 8 and break it down. I would do that with the square root of 10, but the square root of 10 doesn't have any perfect squares in it. It's just the square root of 2 and the square root of 5. You can't break those down anymore. So you multiply them and it just gives you back the square root of 10. But the square root of 8 does have a perfect square in it, 4. The square root of 2 times the square root of 4 will give me the square root of 8. 4 breaks down into just 2. So I have 2 square roots of 2 here. Plus or minus 2 square roots of 2 is the same thing as plus or minus the square root of 8. Okay, now I'm ready to solve. So I want to add 6 to both sides. And like I did in the previous example, it'd be a positive 6 plus or minus 2 square roots of 2. One more step to get x by itself, I need to divide by 3. That means I need to divide everything over here by 3. So x is alone. 6 divided by 3 is 2. I have my plus or minus sign. Then I have 2 over 3, which is 2/3. And then I have a square root of 2 multiplied by that. So this is my final answer. Remember, this represents two solutions here. If you typed in 2 plus 2/3 square roots of 2, you'd get about 2.94. If you typed in your calculator 2 minus 2/3 square roots of 2, you'd get about 1.06. All right, complex square root property. So I'm not going to get into this over here. You're going to see what it means. So we're going to do the same thing. We're going to get the squared by itself. So I need to subtract 8. Those cancel. I get x squared equals negative 8. Well, how do I get x by itself? Oh, I have to square root both sides. Okay, so the square root and the square cancel, and you're left with x equals the square root of negative 8. Now remember, we can't do the square root of negative 8. It's not real. So we're going to have to do the imaginary version. So remember, this is like the square root of negative 1 times the square root of positive 8. So we just worked on this. What this means is I square roots of 8. Okay, so I have a complex number here. A complex number here. Now, square root of 8, like before, we put in simplest radical form. So if you don't remember, it was the square root of 2 times the square root of 4. The square root of 4 is just 2, so we have 2 square roots of 2. So 2 is with the I. It doesn't have a house, but the square root of 2 does have a house. Okay, so this is my final answer here. Now there's something that I did forget. What did I forget? Well, when I square root both sides, keep in mind we still have to do the positive and negative version. See how easy that is to forget? Positive and negative version. Okay, so there's two different answers here. There's positive 2i square roots of 2, and there's negative 2i square roots of 2. So do not forget that. Okay, down here, it looks like the square is isolated, so I'm ready to square root both sides. Right off the bat, after you cancel the square and the square root, and you get x minus 4 equals the square root of negative 3. Immediately when you square root both sides, put plus or minus. That way you won't forget. The square root of a negative, we want to make that imaginary. So we have plus or minus I square roots of positive 3. Now I'm ready to get x by itself, so I want to add 4. 4's cancel, and I get x equals 4 out in front plus or minus I square roots of 3. Okay, I cannot combine these. These aren't like terms. It's 4 plus or minus all of this. Remember, those are two answers. 4 plus I square roots of 3 and 4 minus I square roots of 3. Two solutions in a quadratic equation. All right, down here, my square isn't isolated yet, so I first want to subtract 32. Then I need to divide by 2. Now that my square is alone, I'm ready to square root both sides. Remember, immediately when I square root both sides, I want to put plus or minus. I want to simplify my negative radicand. So it's going to be I square roots of 16, well, the square root of 16 is 4. So this is plus or minus 4i here. I'm going to solve for x, so I need to add 5 to both sides. So it's 5 plus or minus 4i. Last step is to divide by 3. Remember, we're going to divide everything by 3. And I get x equals 5/3 plus or minus 4/3 I for my final answer. Okay, so make sure that you divide the 3 by the 5 and by the 4. And remember, we can't add the 5 with the 4 to make this 9, or we can't subtract to make this 1, because one term has an I and the other doesn't. Those aren't like terms, so to speak. Equations of quadratic form is the next thing that we want to talk about. So both the factoring method and the square root property method, the two that we've just learned, can be applied to non-quadratic equations that are of quadratic form. Well, what does quadratic form mean? It means it has this form, and U could be any algebraic expression. It doesn't have to be just a single letter. It could be the square root of x. It could be x to the third. It could be x squared minus 3. It could be any algebraic expression in for U. So U just stands for some expression. A, B, and C just stand for numbers. Okay, so we've already learned the factoring and the square root property method. Now we're going to use this in quadratic form with non-quadratic equations. Okay, so remember, a quadratic equation has an x squared in it. So non-quadratic equations, they won't have an x squared. Down here it gives some examples. So in the first one, this is the original equation. It says x to the fourth plus 5x squared plus 4. So it's definitely not a quadratic equation because the highest power here is x to the fourth. Well, we can write it in quadratic form. Remember, this is the form that we want to get it in. So a number times an expression squared plus a number times that same expression plus another number. Well, I see that my C is 4, my B looks like it could be 5, and then my A looks like it probably could be 1. So what the heck is U stand for? Well, look at if I squared my U, it has to be x to the 4th. So what x squared would give me x to the 4th? And that'd be x squared. Okay, if I square the x squared, I get back to x to the 4th. So it looks like my U is x squared. Let's see if I could put that in place with the B. So go to your B's position. Is there an x squared there times a B? Yes, there is. And then we obviously have C. So this is the quadratic form here. In this example, the U stands for the x squared. Look at this equation. Doesn't look like it's quadratic, does it? It doesn't have an x squared. It's definitely not quadratic. Okay, so how could I get it or manipulate it to look like this form? I always like to go and look at my middle term, my B term here, because it tells me what my U is. And then I want to check that with my A term. I'm saying, okay, here's my U. If I square it, would it give me the A term? So I'm kind of thinking that my U here is the square root of x. I'm kind of thinking the B is 5 and the U is the square root of x and the C is 6. So if I squared my U like it says to do for it to be in quadratic form, if I squared the square root of x, would that give me x? And the answer is yes. Okay, so my U here, what they're subbing in, is x squared. The A is 1, the B is 5, and the C is 6. The U is the square root of x. Because the square root and the square canceled, I'd be left with x minus 5 square root of x plus 6. Okay, and that's right back to my original. Down here is a little trickier. So again, my hint to you is always look at the middle term and see what you think that U is. To me, it looks like the middle B is 5 and the U is probably x to the 1/3. Okay, so if I squared the x to the 1/3, would I get x to the 2/3? And the answer is yes. So let me do that in a different color. X to the 1/3 squared, well, squared means is the same as 2 over 1. When I have a power raised to another power, I multiply them. So I'm multiplying 1/3 times 2 over 1. When I multiply fractions, I multiply the top numbers. So 2 times 1 is 2. 3 times 1 is 3. Okay, so x to the 1/3 squared is x to the 2/3, and that's what I would get here. So my A is 2, my B is 5, my C is -3, and my U value is x to the 1/3. The bottom one is a little bit tricky. I'm not going to talk about it. I'm never going to give you anything that difficult, hopefully. If I do, let me know, and I'll take it off of your WebAssign. If you're interested in how it works, please come and ask me. I'd be happy to share that with you.